Hi, my name is Natalie Leger, and I'm going to be explaining developmental networks in genetics. So today we're going to be discussing why dragons only have spikes on certain parts of their skin. So these here are two skin cells, and one has spikes and one doesn't, and they both have the exact same DNA. So why are they different? It's because of epigenetics, where things such as proteins can affect the regulation of expression or transcription of the DNA inside the epithelial cells. So we're going to be focusing on these proteins S, P, I, K, and E. And these act as a chain of events that activate and inhibit each other and eventually activate the gene spikes, which causes the expression of the genes that code for spikes on the epithelial cells. So here I've given fictional characters to give relatable interests to these proteins. And the wild type is the king activates the knight, which inhibits the evil witch, which in turn wants to inhibit the princess. So if we inhibit the witch, she won't exist, the princess can't exist, and the princess will give her kindness, creating a strong dragon heart, and in turn create spikes. So let's see what happens when we mutate this developmental network. So, for example, let's get rid of P. So there's nothing going to be inhibiting I, so I will be able to inhibit K, and if there's no K, then K won't be able to promote E, and E won't be able to promote spikes, so spikes will not be formed. So what if we instead inhibit I? So that works because P was going to inhibit I anyway, and if I is inhibited, K will be able to promote E, which then promotes the formation of spikes. So what if we mutated and removed both I and E? If I is inhibited, then it won't be able to inhibit K, which K can then promote E, but since E doesn't exist, it won't be able to promote spikes, so spikes will not be formed. So what if we removed S and K? So if K isn't here to promote P, then P won't be able to inhibit I, and I will then be able to inhibit K, but since K doesn't exist, it won't be able to promote E, and E won't be able to promote spikes, so spikes won't be formed. So mutations of the developmental network can be beneficial when they don't want spikes to form in places, or it's desirable to not have spikes. So, thank you, and here are my references.